Give folks another minute. Did you all secure more supply chains over the last 2 weeks since we missed?
There's a lot of them. Sorry.
There are. We got to the big milestone for Ruby gems, which is that MFA is now required for the owners of the most downloaded gems.
Oh, nice. Congrats.
Yeah, that's been a lot of work.
Was there an announcement about that?
Yeah. I'll dig up the link. Hang on.
Okay. Put that in the notes.
A little bit of the usual sort of like pushback that other ecosystems have seen, but nothing too dramatic.
That's awesome.
I think most people recognize that it's a good idea.
That's good. Here, I'll share my screen. Where is that? There it is. All right, is the agenda up there? Cool. All right, small group today. So I don't know if you, I mean, I'd love to hear the updates and the Fresca demo, but I don't know if you want to wait for a bigger audience, Mike and Parth, but we can kick it off. So anyone new on the call that wants to say hi? Trevor, you look like maybe, have you been here before?
Hi, yeah, I'm Trevor. This is my first time attending. I'm coming out of North Carolina State. I'm a third-year PhD student.
Oh, fun. Nice to meet you. What are you studying, or what's your area?
Primarily, we're getting started in supply chain security as well. Our group at NC State, they just won this frontier that covers the next 5 years from the NSF, targeting supply chain security.
Very cool.
Nice.
Well, yeah. Anyone else want to say a quick hello? Yeah, cool. Okay. Yeah, just a reminder, these meetings are recorded and then uploaded to YouTube too. So folks that can't be here can always watch the recording. All right. So yeah, we kicked it off with a nice announcement with Ruby Gems. There's a link to the announcement there that's requiring MFA now. So that's awesome. Good work on that one. And then, yeah, so the next thing on the agenda is John Speed wants to talk about the compromised data set. So you want to kick it off?
Yeah, glad to. Hi, everyone. I think I've met many of you, but my name is John Speed. I work at ChainGuard, and I do research and development there. And one of the things that has been slowly brewing is the idea of an open source software supply chain compromises data set. This actually began even before I was at ChainGuard on an issue. If you click on that issue link, it should lead, yeah, exactly, to a long thread. It'd be too much to read now, but Abhishek and Kim and others said, hey, we should maintain a list of these open source software compromises, and it would be useful for a variety of reasons. And there happen to be data sets that are related, but none of them quite like this. I'm glad to talk about that. And I, at the time, said, thinking this would be a relatively simple idea, said, hey, well, I've actually been maintaining one of those data sets, but I'm leaving that place. I was at a place called IQT Labs. And it would be nice for OpenSSF to host it and improve it and make it better, have a wider set of collaborators. There's really only me and one In-Q-Tel staff member named Vince Tozer that he and I actively maintained that data set. So what happened is, over a series of months, this spring and early summer, a number of persons, if you click into the design document, collaborated to figure out, well, what would such a data set look like and what would it be do? It looks very modest. I swear it took a surprisingly long time to figure out all this stuff and agree. It's only a page and a half. But the idea is to have a data set hosted by the OpenSSF, potentially under the auspices of this working group, there's actually already a private repo for it, called something like, open source compromises data set. I forget the exact terminology and name that the private repo has, but and we would propose that it tracks open source software compromises. So that's not just malicious compromises, though that would be included, but also vulnerabilities that are known to be compromised. So this is not just a rehash of CVEs, since there are many CVEs that there are no evidence of them being compromised, and not all CVEs are of open source components. And how it would work is there would be these documents that are these YAML documents that are stored and have, I think things you would expect: a name, a class of attack, some other basic information, what ecosystem. But this is all subject to change. And my reason for bringing it up today is if it's to be hosted on this group, it would be wise to get feedback from anyone who is curious and interested. I think this data set will be an asset in the long term to the OpenSSF, the Integrity Working Group, and to anyone interested in software supply chain security, specifically open source software supply chain security. So feel free to leave comments, make questions. You can, I can talk about it right now too more. But the proposal concretely is I'll give it 2 weeks for anyone to make, ask questions, make comments, throw tomatoes. You can DM me on Slack if you don't want to do it through here. And then what I would propose to do is this: anybody who's interested, we would start prospectively, making this repo public, and then making entries for attacks that happen in the future. And we would do that for a few months, and if it seemed useful and it worked, then we could try to add in past attacks. But that's kind of one of those things that's it's just hard to do. There's only so much time in the day. So how we make it easier is just collecting data on new attacks. And so I'm sure if you have questions, I'm glad to take them. Thanks for Kim for letting me have a slot today.
Questions, comments? Oh yeah, we see a couple. Jacques?
Yeah, I think this is a great idea. I was curious about how you see it, or whether you see like existing firms contributing to this. Like a lot of security firms have their own data sets, including exploit detections, which is really useful. The chain of thought that led me to that question was actually indirect, which was maybe we could talk to first Forum of Incident Responders and Security Teams, who are the custodians of CVSS, not that many S's, but also one called EPSS, Exploit Probability Scoring System, which relies on data from, I can't recall which vendor, it was Synopsys or Qualys or one of them.
Yeah, I would be glad to talk to these persons, especially if you knew them and were willing to make an introduction and make it so these people, knew what was going on. I would enjoy that. I certainly, I think a stretch goal, just because I'm ignorant and inexpert, I'm unwilling to make it like a permanent goal, but it would be very nice if it was helpful to, this data set could be helpful to threat intelligence feeds, or, people who want to not simply researchers, I myself am a researcher, but to people who want to operationally use this data. And I think that would be enhanced by talking to the parties you described. So if you're willing to do an introduction, Jax, yes, please.
Yeah, I'll try to do that. Please ping me after this and I'll dish out emails.
Sounds good. Thank you.
Aaron?
So I actually just had a conversation with someone from Checkmarks over when I was at DEF CON about, I think, this kind of idea. Oftentimes you'll find an open source project might have been compromised. Let's say somehow miraculously JQ 1.7 is released, right? And it's actually a compromise of an account. and everyone pulls that, right? And so what often happens is the actual repo that was compromised is deleted altogether. So there's not actually a fingerprint any longer of that. So I think what you're talking about, John Speed, is like addressing that, because like, sure, like it might have, like, it might be a known thing like that could be exploited, but now that is just erased all entirely, and people don't know that they shouldn't be using JQ 1.7 because it's just gone, maybe. So maybe that's what you're trying to address, because I think that'd be great.
I do think that is what I'm trying to address. I mean, I think I've heard at least one registry maintainer concede some registries right now just blow up bad artifacts that get found and they disappear, and it's a shame on a couple different levels, both that the artifact no exists, there's no record of the artifact existing, and this is at least the record of the artifact. The actual collection of the artifact itself I think is a better fit for other endeavors, especially Mark Ohm's backsevers my collection data set, but I hope it can at least partially address that.
I had a related note, which is we've discussed the idea of storing the artifacts or collecting artifacts in the securing software repos group, because
Cool.
it is a common researcher request to get a hold of those. And, we want to have a collection, but we don't want to just hand it out willy-nilly.
Yes. Yeah, strongly agree. I'm sure you've discussed this. I think the Python package index maintainers feel similarly. Not that I have anything I'm sure you've thought about more deeply, but if I can help, or you think there's some sort of way, or if there's something I can do to make that a more likely reality, please let me know.
Awesome. Any other questions, comments? Cool. Awesome. Thanks, John Speed.
Thank you.
Mike, you are on the hot seat with some salsa.
Cool. So yeah, just wanted to give folks who maybe aren't in the salsa meetings a quick update on some of the work that's happening on that front. So we've been doing a big push regarding hitting 1.0. So as a reminder for folks who are sort of familiar with salsa but not very familiar, salsa is currently, I believe, 0.1 for the actual rules, 0.2 for the spec. We are looking to make salsa 1.0 in the coming months. So that means like it's going to be an official sort of production release, as in, here's a set of requirements that we feel, is something that we want to kind of put out there and get really drive folks to adopt. And so with that has come sort of 4 work stream, or I'm not going to overload because the depending on the OpenSSF, there's a lot of different work streams, blah, blah, blah. Anyway, there's a bunch of work meetings for these things. So first off is the specification meeting. And I, put the link to sort of this, the SIGs or whatever we want to call it, inside the notes for this meeting. And so it has all the time and notes and for those meetings. But the main thing is, so there's a specification meeting. The specification meeting is focused on actually defining the requirements as well as the JSON sort of specification for the provenance metadata. And so that's one of the work streams that's happening on that. And so there's a bunch of related work on that. There is next up on that list is the tooling meeting. So that's one that I co-lead, and that one is focused on sort of identifying what software is out there that is looking to sort of either as a salsa builder or work to sort of ingest salsa and those sorts of things, and as well as sort of identify gaps in tools and identify gaps potentially in existing tools that you might want to integrate with salsa, for example, like Jenkins or something like that. So that's the some of the stuff that we're doing in the tooling meeting, and that's kind of focused a little bit more on hands-on keyboard, like, you know, actual sort of development work. There is the positioning group, mostly led by Melba, and I believe Bruno is the backup on that one. And that the positioning group is you know, focused around sort of identifying different areas in the community where similar sort of work is done and where we can collaborate and where we should make sure that like salsa is, you know, if folks aren't aware of salsa, we need to make sure that salsa is made aware of, because we want to make sure that, you know, folks don't just sort of in another corner of our sort of industry. We want to make sure that, you know, nobody just sort of reinvents salsa again, and then we have potentially sort of competing standards and that sort of thing. And actually, I think Melba is on if you wanted to maybe talk a little bit more about the positioning group.
Yeah, sure. Yeah, and we're also trying to do like the mappings, like Mike said. We have a spreadsheet to say, okay, these are the salsa levels, and if you are following, let's say, like NIST 800-161, these controls are met by salsa levels 1, 2, 3 requirement for provenance, as an example. So we're looking for feedback so that way we can finalize it and bring it to the OpenSSF so that it is an official OpenSSF document. And additionally, we're trying to make the visualization of, you know, end-to-end supply chain, how it maps to salsa, how it maps to the other frameworks. And that's the doc or the PDF that I put in the agenda. I already got notes or feedback from the last meeting and looking to expand to other members in the community, so we can kind of incorporate other use cases that maybe we're not thinking about in the positioning meeting.
Cool. And then the other group, which hasn't been spun up quite yet, is the adoption group. So once we have more or less like a real good understanding of what specification looks like for 1.0, and we have a good idea of what needs to get done from a tooling perspective for 1.0, and then as sort of Melba had mentioned, you know, what sorts of, you know, as long as we start to kind of start having those conversations with the right groups and we start doing the right mappings, then we'll have a good story for how we want folks to start adopting salsa at a broader level. And when that happens, hopefully in the next few weeks, probably in September, we will spin up the adoption work stream. And that stream will be focused on, you know, driving adoption, getting sort of average folks and projects to start adopting the salsa specification, the salsa tooling, as well as, you know, helping them out through stuff like the mapping so that they can kind of look at, as Melba had mentioned, you know, here's how salsa sort of helps out with what you're doing with NIST 800-161 and vice versa. Any questions?
Sebastian?
Thank you. I was interested to know where this lies in terms of the interaction between open source projects, which are distributed to a wide group of people, and customer-supplier relationships.
So it's for both. So the idea is, you know, you can imagine that a vendor provides a salsa attestation to their customers, and or potentially, you know, one of the other things that's being discussed in stuff like the positioning meeting and the specification meeting, there are some things that we're looking at. If, let's say, somebody says, hey, we believe elements of how we the metadata associated with our build is potentially proprietary, there's discussion about, you know, third-party auditors under, you know, sort of NDA and that sort of thing can sort of provide third-party attestations on other people's, you know, build systems and that kind of thing.
Yeah, I was just going to add the original motivation of Salsa was for open source projects and helping the open source ecosystem, but there's no reason why the framework and the specification can't be applied to kind of closed source vendored software as well. I think it still holds true.
Thank you. I was interested in this because part of the provenance specification says that formats are agreed upon between the consumer and supplier. And it occurred to me that it would be very hard to please everyone when you have an potentially unlimited number of customers.
Yes, but I think what we're trying to drive is we're trying to kind of say that if, for example, you have to use something that's not the Salsa provenance specification for some reason, we're saying still following the Salsa requirements is still valuable. But I think the thing on that front, we highly recommend, if you can, use the Salsa provenance specification because it's slowly but surely becoming a widely adopted spec in the space.
Thank you. Very interesting, and looking forward to see how it develops in the future.
Cool. Any other questions on that? No. Yeah, the last thing, the Salsa meetings are tomorrow, like the day after these meetings at the same time. So if you want to join kind of the main overarching meeting, we welcome all new folks to that one too. Cool. All right, moving on. Last topic. Looks like we're getting a nice demo. So Parth, do you want to take it away? Feel free to take over the screen too.
Yes. All right. I think you need to stop sharing. Okay, perfect. Okay. All right. Hope everybody can see this. Is this readable? I can make it a little bit bigger. Let me know. Does that look good? All right. So I think so this project is called Fresca, and it's under the under this working group, the integrity working group. So kind of want to show up some of the features. I think a lot of people are aware of, you know, what the kind of focus was. Is like this is supposed to be based off the reference architecture. So that's what I have here. So the CNCF reference architecture for the secure software factory that got created. So it's kind of an implementation of that. So multiple different pieces are all accounted for. I'm sorry.
Oh yeah, and just also one thing to just highlight is it's both a combination of the CNCF secure software factory reference architecture, as well as trying to kind of be the cutting edge of what you can achieve with Salsa, as well as similar sorts of frameworks like the SSDF.
Right. So I think the major pieces, I'm just gonna walk through those major pieces. I think a lot of people are aware, but just for people that are not, basically, right, this is the build environment that we're using is Tecton in this piece. For the identity workload attestation, node attestation, we're using Spire. The pipeline observer is going to be the Tecton chains piece. And then for runtime visibility, which is going to be part of this demo, is going to be Tetragon, which is actually in this separate cluster here that's running. And then we also have Vault also in here. So Vault is integrated with Spire using OIDC so that it can actually fetch the signing keys, so that keys are no longer being stored as a secret in the Kubernetes space. You can have it stored in Vault, and using the transitive plugins, you can it can do the signing for the images and so forth without the key ever leaving the Vault. So the main piece that I wanted to focus on today is how this is obtains Salsa level 3. So let me close this out. So this is the main piece that we're going to talk about, and this diagram kind of explains how it achieves this piece. So what happens is that the Spire server and the Spire agent, or Spire server, is registered with both the Tecton pipelines controller and Tecton chains. You can see that in this diagram. But what happens is that there are multiple SVIDs generated, right? Multiple short-lived certificates that are generated for both the task run itself. So as a task run is running, it's going to generate a specific SVID that's valid for it only. And then there's also another SVID that's for the controller. So both these two certificates are used in conjunction to sign and verify different aspects of as the task itself is running. So the first piece that I will show is basically, I think, a valid, a good example of exactly what happens. So I ran this quickly beforehand, so that so that we didn't have to kind of wait for it to finish. So you can see, let me finish loading. Okay. So in Crane, this is using Crane LS. Basically, you can see that a signature and attestation was associated with this, right? So chains automatically does signing and creates the salsa attestation, and it pushes that into OCI, so that you can see that this image that got created by this task was able to be signed and attested. But the main piece is how does Spire kind of integrate with this? So the first thing you see in here is that there are a bunch of, there's a bunch of keys and signatures now in here. So let me scroll up a little bit. All right. So now what happens is that whenever a task runs, when a task actually instantiates, it's gonna request a certificate from Spire, and Spire is going to validate that it has a proper UID, it has a proper service account, whatever namespace, everything that's running in. And if it validates that, it's going to provide this specific task run an SVID, a certificate that it can use for signing. So you can see that SVID right here. Here's our certificate kind of stored in here as a status annotation. And what is happening is that in this specific case is that the results that are coming out, so basically it's checking to see that the results are not modified during the execution and when the task is actually finished. So in this case, there are two results that are coming out. So the results that are coming out is the actual the image ID and the digest. Those are two things that are coming out. So what happens is that it and that is up here, I believe. Let me see if I scroll down. Yep, so here it is. So these two things, the image URL and image digest, are the two results that are coming out. So it signs those two results to make sure that at the end, once a task is actually finished or the pipeline is actually finished, it can go back and verify, yes, these are the results that came out. They were not modified either during or after the pipeline actually finished. The other piece that it does is that it also checks for tamper proof. Like, so basically, as the pipeline itself was running, did somebody tamper with it? Did somebody change the image that was being used, right? The image ID for one of the steps that was being used. Did they change, like, an exit code or something? They changed something as the actual pipeline was running that invalidated the results. So that's the other piece that comes into play, and that's using another SVID, which is a controller's SVID, which is this Tecton Pipelines controller. And it kind of takes a status. It takes the hash of this whole status, the status object here in the CRD, and it signs that using the SVID that's provided. So at the end, again, it checks to see, it continuously is checking to see if anything has modified the task itself, the task run itself as it's progressing through the pipeline. If it has been modified by anything except for the pipeline controller, then it invalidates the whole pipeline, and now the results will no longer be signed. So at the end, basically, the change is actually validating that the results are valid. So you can see here, there's a condition that's set that all the results are validated by Spire, and it also checks this annotation here to see that the status at the end, does the status match, and everything kind of lines up. And if it doesn't line up, that automatically invalidates, and that means that the image is no longer signed and it's not pushed to OCI. So you at the end you might get an image, but it's not signed. There's no annotation associated with it, so it's going to fail the the upstream admission controllers such as Kyverno. Is going to fail those kind of checks where it's checking for signatures and attestations.
Yeah, I think it's really worth sort of highlighting what that means. So that means even an admin on your Kubernetes cluster that's running your build, if they were to modify a build while it's running, it wouldn't get signed. Exactly. The same thing goes with, let's say, if there was a supply chain attack against the build to a particular component of the build, and that particular component tries to modify another component of the build, right, it would get detected and would not get pushed out and signed.
Yep. So I think what I'll show right now is basically a long running task. So just a quick example, so you can see this is the actual task run that's getting run. Very simple. This is a hello world. So basically what I'm gonna simulate in this is that, you know, like Mike was saying, some bad actor, cluster admin kind of comes in. Let's say, oh, I want to modify this image, right? I want to use, instead of using the image that's provided here, I want to use some other compromised image that, you know, has some kind of a backdoor or whatever else it wants to do, kind of modify the output. So what this is going to do is that as it's running, so the piece I told you about, that it's going to be continuously validating that the actual task object itself hasn't changed. So it's going to catch that. So as it's running, it's going to be, initially it's going to start out with Ubuntu, and it's going to change to some other image that's not Ubuntu anymore. And we're going to Tecton chains along with Spire is going to catch that has changed, and it's going to invalidate the whole result. So it's going to let this finish running. Right, so it finished running. So you can, if I scroll up here, you can see some of the stuff has changed, but like basically is, you can see in here that it's no longer verified. So it failed. So the results didn't come out properly either. So it failed both the results check. It also failed the verification check, because if I scroll down here now, you can see the image now changed to not Ubuntu. So as it was running, I modified the image as it was running, and then it caught that, embedded that. So now it's no longer. So if I scroll up, Page tries to check it multiple times, it fails, and it try to sign it, it didn't catch. Because it was no longer valid, Spire is not going to sign it. There's no attestation associated with it. Yes. Any questions? Yes, this is a lot of components that kind of work along with it, but that's kind of the main demo kind of wanted to show is like how is it providing, you know, SLSA level 3 non-falsifiable provenance, as well as how is it tamper evident, right? So if anything ever tries to do anything you know, during the build time, it's going to catch all those kind of things. So for example, like the SolarWinds thing that happened, right? This would catch that from occurring. Any questions, comments?
Speaking of SolarWinds, Mike, you might actually know the answer to this one too. So we had a presentation at was one of the conferences, and Trevor, who was at SolarWinds at the time, did a presentation of how they rebuilt their systems after the attack, and I believe it looked very similar to this sort of architecture. Do you remember, Mike? Well, the similarities, like they started using Tecton and.
Yeah, they started using Tecton. They also started building across multiple installations, right, that were similar but not identical, that allowed them to sort of run the same sort of build and then run a bunch of tests against those things to make sure, like, did they largely build the same sort of things? Like their builds were not truly reproducible, so they couldn't actually bit for bit sort that out, but they could, in the very least, sort of run it against multiple build clusters. And so you would have to sort of compromise multiple of those clusters in order to kind of do that. Yeah, so this is similar. And yeah, this is also a lot of the stuff that we had brought into stuff like the secure software factory reference architecture, is a lot of that sort of learnings from things like that as well. Yeah, and I think the thing here that you know, we really want to sort of drive home is, you know, a lot of this sort of stuff is not, you know, like in Fresca, right, is stuff that you just also get for free, right? It's not like when you install Fresca, this sort of stuff is already by and large set up for you. You don't have to spend a lot of time, you know, configuring all the different pieces to make sure that they wire together correctly and yada yada. And yeah, so if folks want to kind of understand more about that, we have the Fresca community meetings every other Wednesday. So it's not this week, but it'll be next week at was it 10 a.m. Eastern time? which I know doesn't work for everybody, but it's one of the few times where there's not an overlap with another OpenSSF meeting. And so, we're definitely looking for more folks, to contribute, to maybe use and provide feedback on, and so on. And we're hoping to also, in probably the coming months, get a threat model done against Streka, so that, folks can sort of see some of this sort of stuff, right? Yeah.
Yeah, exactly. I kind of just want to reiterate that, it's kind of all behind the scenes, right? All the Spire stuff, all the things that you're kind of doing. That's not really adding any kind of extra work for the actual developer, right? So they just checking their code. Basically, I had this triggering on a pull request, so automatically, so I have a GitHub. It's connected to my GitHub. It triggers the building of the pipeline on my pull request, and that's it. Like, it's going to create you the image at the end of the day. And if all the checks and verifications pass, you're good to go. So you can put it into push it into production or put it into a test environment, whatever you want to do, and it'll do all that for you. So, like, there's nothing extra getting done. At the same time, the Kyverno is running here, which is the admission controller. And again, that's also continuously validating that, hey, are you using the proper images? Are you using the images that are signed, that you trust? Are you using images that have specific attestations associated with them, like all that kind of stuff, as it's built during the build process, as well as, if you're pushing it out to production, right? It's going to continuously validate all those kind of things. So basically, kind of creating a zero trust environment for your build. And then, so moving on, so I want to show this real quick also. So this is still a work in progress, but the other piece that I'm trying to, that we're trying to do is, make it a little bit bigger here, is get runtime attestations. So create runtime attestations that are separate from the build time attestations. So what chains will create salsa attestations, right? For the actual build. Now we also want to go a bit further and capture what is actually happening during runtime for the actual build. So as a task is executing, what kind of syscalls processes, what's happening, right? So if I want to know in the future that it's reaching out to malware.com or something during the build, and that I wasn't aware of, right? Then I want to know that piece. So if we can create the attestations associated with those as they're building, we can use future like policy checkers such as Kyverno to check to see, did this piece, did it reach out to the internet? If it did reach out to the internet, then, and I didn't expect that, then you can automatically say, like, okay, I'm not going to allow it to run in my production environment because it reached out to the internet when it was not supposed to. So I have this integrated with Tecton chains. So basically, again, it's nothing that the developer kind of needs to do more. Tetragon kind of runs in the background along with chains, and it's just monitoring all the tasks that are running. So once it runs, so let me just kick that off here. So task run. So you can see that this is running. So basically nothing really changes in terms of how pipelines or Tecton change runs. The only thing that really happens in the end. So this one's gonna run. So I'm just gonna look at an older one that I have here. So you can see in here that now instead of just the salsa attestation that got generated by Tecton chains, now there's also a runtime payload. So this runtime payload is basically another predicate type that we're actually kind of going forward with now. So I'm kind of working with the folks from Intoto and such, so we can create a new predicate type for the actual runtime, and capture this, the specific information that we need. So just to show you what this kind of looks like, this was the runtime payload, and again, this is just a rough draft, but basically it kind of prints out a lot of. I am simplifying the output here into like a string format because of course it puts out a lot of information. So I think the next piece of this is basically what should this predicate look like and what kind of information do we want to capture in here. So I know we want to capture, like TCP connections, all those kind of things. Any other things that we want to capture, like, okay, is it touching specific files? What is it doing? Is it modifying things? We want to capture those kind of information. So that's the next step is, okay, defining, it's getting a lot of data, but what data do we care about and what data do we want to keep? and then so that we can use that for future, to create policies, and that we can use for admission controllers and such. So you can see in here, it did a bunch of things, and it automatically generates this for each of the different tasks that get run. And again, you can push it to OCI, and it will do signatures associated with it, everything kind of similar to how Change does everything. So any questions on this piece?
I think Sebastian has a question.
Yes, go ahead.
We can't hear you if you're speaking.
Sorry, thank you. So I was wondering, if Tetragon was disabled, how would that manifest itself in the build? How would you know that that attack had been performed?
So you would not get the because Change expects Tetragon to be enabled and running, right? So Change itself will start throwing out saying, like, oh, there was not, Tetragon is not there, it's not configured, and so on and so forth. And also at the same time, this runtime attestation would not be generated, right? So that's another piece that you would see if you're expecting a runtime attestation to be created and pushed to your OCI registry, let's say, right? It doesn't exist anymore. So even if that happened, your admission controller in the future should be able to catch that, saying like, I'll expect a runtime attestation to exist for this piece. It doesn't, so now I know something upstream has gone wrong, and I'm not going to allow this release to be pushed into a production environment.
Yes, so presumably the runtime attestation would contain data that's linked to the source code of a build, so that it cannot be completely falsified and pushed manually.
Right. Yes.
Right. I see. Thank you.
So I'll just jump in next because I have my hand raised, so I don't know if you get called on. I see the runtime attestation seems really neat. I'm kind of visualizing it in my brain like you're playing a racing game and you have to get to the next checkpoint to continue. So if it's not there, then it doesn't continue. Curious though, if you guys have thought about, I know this is like very active development, the historic attestations, is there sort of like cleanup, or because I could see that getting a little deep and messy, right?
What do
Yeah,
you mean
so
by, go ahead. Yeah. Go ahead.
oh, I
Mike.
was gonna say, yeah, I mean, this sort of stuff like would get associated with whatever is getting sort of built. So if you clean up old artifacts,
Yeah.
this would get cleaned up with those old artifacts, but it's associated, like the idea should be to associate it with every artifact that you are potentially building, especially artifacts that you're like, hey, this is intended to be a production artifact. You want to associate all those different attestations with them. And then the idea also would be, and this is something that we're working on in conjunction with Google, which is that thing that I believe Brendan Lum, I think, showed off at either this meeting or it was at Salsa recently, which is a project that we're calling Guac now, which is a sort of a graph for sort of like associating all this metadata so that you can then get the historic, so that you can look at it historically. And some of the stuff that we would love to do long term is start to detect sort of anomalous behavior. Like if a build mostly does these 5 things time and again, and all of a sudden it starts doing a different set, a completely different set of things, that is not necessarily indication of malicious behavior, but you might want to highlight, hey, whoa, hold on, this didn't reach out to the internet before. Now all of a sudden it is trying to reach out to the internet. Is that a bad thing? Is it just a mistake or whatever? And this sort of thing helps us detect that, because the key sort of pillars behind the secure software factory, and therefore Fresca, is you want to make sure that the pipelines you're running, like the actual sort of as code that you've written up, you want to make sure that stuff, there's policy behind it, so that generally, are you running the right steps in the right order? Are you, if your security demands, you should have a software, an SCA scan or a security linting scan or whatever. If that sort of demands that, well, make sure that that's actually running. We don't want to sign off on images that didn't go through the right process, right? So that's one piece of it, and we're controlling that through stuff like the Kyverno policy, as well as our abstraction layers built on Q. queue line. And then we're also looking at stuff like then the workload stuff that Parth had shown, the node and workload stuff that Parth had shown with Spiffy Spire, helps us sort of say, okay, great. If somebody messes with actually like an admin messes and exchanges a thing, or if another service inside of the build with adequate permissions tries to mess with the thing, we want to be able to detect it. And then then the last piece, which what Parth showed as well, is okay, runtime visibility helps out because Spiffy Spire and that component can detect if somebody has swapped out with a bad image or tried to swap out a task with different parameters, that kind of thing. But it doesn't detect if somebody shelled in, or doesn't detect if somebody actually attached the container and is doing something, or if a dependency that you're actually running as part of the build is trying to do something nefarious. Like you could imagine some of the NPM packages that have been compromised in the past, where it starts to sort of poke around and look at the .ssh folder and all those sorts of things and starts trying to do stuff there. So you can imagine with this runtime visibility, hey, if you start to detect that sort of behavior, whoa, that's bad. We don't want that. And you can you can sort of block that from getting signed eventually as we build this out, as well as in the very least audit it, right? You have that sort of record of what actually happened in the build at the runtime. And you can always go back and say, hey, this thing that we published to production is acting really strange. And then we go back and go, oh no, like this is what happened. And we have that information available to us.
Very cool. Any other questions or comments for Parth or Mike? No? All right, well, thank you so much for the demo, and we'll get out a little early today. Thanks, everyone.
Thank you.
See ya.
Thank you. Bye.
Ready? Bye.
Bye, everyone.
Well, that was good. I mean, thank you very much. Bye.